And check.
Yeah.
All right. So right here, we're in your reference booklet. We're right underneath your quad family tree. Swing around, shove your desk together with your quad mates now. Your assigned quad mates. Your assigned quad mates, please. All right. You have 3 statements, 1, 2, and 3. As a team, I want you to read those aloud and try to fill in those blanks. Ready? Go. It's right underneath the quad family tree. Right here. It's right underneath the quad family tree. Right here. You're going to read this out loud and you're going to fill in those 3 sentences. Yeah, let's not send those family. They can kind of road. Wait, just stop. What's the first row ever? Out loud and actually try to figure that out. Okay, this team, you need to be a little bit more cohesive. I told you to read something 45 seconds ago and no one has said anything out loud. So let's start reading. 1, 2, 3, go. This team needs to read out loud. I gave you instructions approximately 45 seconds ago.
No, what's this? Parallel line tab.
Who's parallel line tab?
Read these out loud and get those blanks.
Miss White?
Yes, sir. I'll be right there. Put 4 brains together. I'm not helping with this. We're going to go over it in about 30 seconds. Just read it out loud. If you read it out loud, it's pretty common sense.
I just don't know what it is. Oh, wait.
Where?
Oh, what's parallel line tab?
Well, what is the property of slope and parallel? Like this one. Lines that are parallel have the same what? No, not one angle. There's a tilt issue. Say same tilt. What's the word we use for tilt? Midpoint, slope, or distance? Exactly. So parallel lines have equal slope. All righty. Matthew, statement number 1, read it out loud, fill in the yellow blanks. Go.
The midpoint equation will show something bisecting that has a common median.
Has a common, not a median. Middle, yes. Middle or midpoint is what we want here. Middle or midpoint. Great. Sanal, number 2, please, and fill in the greens for us. Okay, perpendicular lines. The slopes are opposite reciprocal. Slope times slope should equal -1. There is one exception to this rule. Put a little asterisk there. And in the top margin, put an asterisk. Watch very carefully. 0 over any number. That's rise over run. That means I have no rise, which means it's a horizontal line, and you have 0 slope. 0 over any number is just 0. Always. This is going to come up in today's lesson. This one, any number over 0 is a vertical line because now it has no run, no left, right, which means it is undefined. Undefined and 0 slope still make a right angle. That's the only exception there. So if you have something completely horizontal and vertical, go like this. Say horizontal, horizontal, arms, horizontal. Say 0 slope. Go like this. Say undefined. Does that make a right angle?
Yes.
Yes. Any other The tilt is slope times slope equals -1. We'll make a right angle. All right, the last one. Allie, could you read the number 3 statement, fill in the blues for us, ma'am?
So length equal and
Okay, read from the beginning,
the
dear.
whole thing, the distance equation shows comparative length. It
Uh-huh.
can show two lengths are equal in measure or congruent.
Yes, equal in measure or congruent. Okay, we are not doing the math for the next 3. I'm just going to show you the templates. If I'm given all these points, and I want to prove this shape is a parallelogram, there's 5 ways. O, C, D. Ready? I say it, you fill in the last little blank. The first O is opposite sides are what? Go like this with your arm, say parallel. That's kind of definition, parallelogram. Second one, opposite sides are also what? Equal in length. The third one, opposite angles are? Opposite angles are? Congruent. The fourth one, consecutive angles add up to? Last one, diagonals bisect. Now, we cannot use midpoint, slope, and distance with angles. So we can't use these. So we have 3 methods to prove a parallelogram. The first one is to show opposite sides are what? Parallel. That would be a slope concept. Watch. I'm not going to do the math. I'm just going to show you. You would do AB slope, DC slope, AD slope, BC slope. Just copy down the template so you have it. So to prove opposite sides are parallel, you would have to do the slope equation how many times? Out loud, how many times? 4. Not just 2, 4. Okay, flip the page over. I could also show opposite sides are congruent, which means I would use the distance equation. Again, just write the templates. That's it. Opposite sides congruent. I would show the reds are congruent using the distance equation. I would show the blues are congruent using the distance equation. Yeah, the red should be ABDC and then AD and BC. You are correct. That's a very terrible B there. Yeah, you don't have to fill in. Oh, it would be X and X, yes. It would be XX, YY. Again, and this, if you want to know the equation, that's X minus X, Y minus Y. Let me write one of those in so there's no confusion. X's, Y's. Doesn't matter whether you go left, right, or right, left. No. So if I want to show opposite sides are congruent, how many times am I using the distance equation? 4, because you have 4 sides. Okay, here's the shortest method and the last one. Draw in your diagonals, A to C and B to D. And then you would find the midpoint. That's X plus X over 2, Y plus Y over 2. And if you can show that it's the same midpoint going both directions, so hatch mark here in OCD, that would show diagonals bisect. That one you only have to do twice. When you're finished writing that down, go to page 7 in today's handout. When you're finished writing that down, go to page 7 in today's handout. Page 7, you are looking at this page right here. I want you and your teammates, you're going to read every single word on page 7, top to bottom. You're going to rotate your readers. One person reads the given information, and then instantly, I want you to actually label your corners with the given information. 1, 2, 3, 4. You read this sentence, and then as a team discuss these two blanks. You read this sentence, and then that blank. I'm going to regroup with you in approximately 3 minutes. Go, start reading.
You're on number 7. Plotted on the graph. A, is a rhombus with
Yeah, so ask yourself, what makes a rhombus a rhombus? 4 sides, that's number 1. No, because that is not unique to a rhombus. Oh, unique to a rhombus. I think that is one of the two qualities that make a parallelogram turn into a rhombus. So unique to a rhombus.
Right.
Two sides equal.
No. What did we say?
The middle is 93. Yeah, the middle is 93.
Yeah, so if you wanted to show all sides were equal length, Ruby, would you use midpoint? That's the point. Math has meaning.
So you use
Show your map, look to the right.
It is, you just have to have a little bit of.
Do you guys talk anymore?
Yeah, it's really nice. I think I made one. Not yet. I know I have hysterical. I know, watching now. Okay, let's kind of regroup here. All right, so we have this image, and this is called a double proof. Get used to that. You're going to see at least 2 or 3 of these on our next test. You have to prove, it's called a positive. I need to positively prove it's a rhombus, but then negatively disprove it can't be a square. Whoa. So on that note, Chad, give me one of 2 qualities that makes a rhombus completely unique.
2 sides are congruent.
That would be also with a parallelogram. So unique to a rhombus.
Parallel sides.
That's also a parallelogram. Try again. I know you know this. What makes a rhombus a rhombus? Unique to a rhombus. Well, a parallelogram has opposite sides which are equal, right? What's unique to a rhombus? That's going to be one of them. Thumbs up if your team got that somewhere, 1 or 2. That's correct. Just give me just a second. 4 congruent side lengths. And then Talia, if I wanted to show the 4 sides are equal in length, would that be a midpoint, a slope, or a distance concept? It would be distance. And how many times would you have to use it?
4.
4 times. So just in the margin, write 4 times. Good. Jackson, what is another unique quality to a rhombus compared to a parallelogram?
It bisects the angles.
You're right, absolutely, but I can't show that on a coordinate plane. Give me one more. It does have to do with the diagonals.
Right angle.
Boom. Where?
In the middle.
You're so correct. So the second one, you should have the fact that diagonals would be perpendicular. Thumbs up if your team said that. Fabulous. Okay, Matthew Rock, if I want to show diagonals are perpendicular, is that a slope, midpoint, or distance concept?
The slope.
Yes.
That'd be slope.
That'd be slope. And then how many times would I have to do it?
4 times.
No, how many diagonals do I have?
2.
Only 2. So to do this, you would only have to use the slope twice. Put the little or between. If you're going to do a proof, you only need one of those 2. Then that's for the positive. The negative is prove to me mathematically it's not a square. And what I don't want is what I call the dun. It doesn't look like a square, Miss Way, so it's not a square. You need math involved. So Ani, what is unique to a square that's not in a rhombus? There's only one quality.
Right angle?
Where?
Everywhere.
A little bit more. They both have a right angle in the middle, so that's not common. Corners is what we're fishing for. So, right angle corners. Okay, Keegan, is that a midpoint, slope, or distance concept?
That'd be slope.
It'd be slope, and you only need to do a pair of consecutive sides. You don't need to do all 4. This is called a double proof. Positive, negative. Okay, students, you have about 35 minutes to finish all the way through page 8. Get a move on. I'm happy to help. Talia, yes, ma'am. Name in the list. Yes, Patrick, your question. No, I'm going to say that.
Perpendicular diagonals.
Here, Patrick, I'll do a sign up and then we'll chit chat for a second. Let me stop this, stop the recording.